We are going to read about one topic in which I am going to tell you that the North Star, also known as Polaris, is going to die out. So, uh, up there is a Polaris star is there. Polaris, or you can say we say it the polar star or the North Star because it points always towards the north. That's why. But it is not just one star. It is a combination of three star system. Polaris A, then we have the Polaris B and Polaris AB, and one big star which circles them in every 30 years, known as Polaris B. So this is a three star system, but it looks one star from far. Suppose there are two planks of wood and we can see by our naked eyes to them 2 kilometers far, so it will appear to us a one plank. It will appear to us a one plank. That's why. And we know that from 1911 scientists have been studying the Polaris, and it is a Cepheid variable star. Cepheid variable stars are the stars which dims and bright. अब dim bright क्या होते हैं? Dim bright वो स्टार होते हैं which are dying out. Which are dying out means they can die. Yeah. So this is pulsation period of the Polaris. From 1850, it has risen up the pulsation period. Then suddenly in 1960s, it dimmed. Then it again rose for next 30 years. And after that, in the early 1990s, it dropped again till the day today. It is dropping the pulsation period of the Polaris star. Pulsation period means which is dim bright, and because of this Cepheid variable stars like Betelgeuse can be, जो Betelgeuse star है which is the closest to us, it can, which is closest, जो कि कभी फट सकता है, जो कभी मर सकता है, वो हमारा क्लोजेस्ट स्टार है, क्लोजेस्ट जो कभी मर सकता है. लेकिन बट the Cepheid variable polar star is only, polar star has a very important role for us. Let me tell you why. If you see a northern sky time lapse, then all the stars will be looking to move because of Earth's rotation, but the polar star doesn't move. This is a three star system, see, but it is looking like a one star over there. So the polar star doesn't move. That's why it is very important. And because of this, all the satellites, all the ground based satellites are matched with the polar star. Okay, so their ascendantry is matched with the polar star. So let me tell you a time graph. When any star like sun is born, its temperature is there. In this graph you can see its temperature and its surface light is just over there. When the stars grows old, it enters this phase. This is the main sequence. Our sun is now in there. Yeah. After it grows to a red dwarf, it grows in this phase where it has its temperature and its light is too much. So this phase continues for 1 billion years, and after this the stars expand and burst out. Then it quickly moves into the white dwarf phase. There the temperature is too high, but the light is reduced of the star. So pulsation period. Now like इसी में एक और होता है, for Cepheid variable stars, this part. But in this part, the pulsation always grows for any Cepheid variable star, but like this. It grows for any normal star like this. But scientists are saying it, and they are observing that 4.5 seconds every year its pulsation period is decreasing. You can see over here the pulsation period is rising and then dim, rising then dip and then again rising. When it's rising in every 29.5 years, and recall 29.5 years can be written as 30 years too. And if we recall what happening with in every 30 years, जो पोलारिस बी है वो एक पूरा चक्कर लगा लेता है ए और बी की जोड़ी के, तो ए बी के जोड़ी के पोलारिस बी एक पूरा चक्कर लगा लेता है इन एवरी 30 years ऑलमोस्ट. So in every 30 years it grows, but suddenly it dip and then it starts to grow and then again dip. So I might think, scientists may thinking that when they both are there, they both are doing some radiations they are emitting, so they have one atmosphere, they both have one atmosphere, like corona is the atmosphere for the sun. Then जब वो इसके पास आता है, इनके पास आता है, तो इसका एटमॉस्फेयर और इसका एटमॉस्फेयर कोलाइड हो सकता है, जिससे इसका पल्सेशन पीरियड कम हो रहा है. मे बी दैट इज द केस. और when every hydrogen atom in the star converts into helium ions, then the core and the radiation expands, but the gravity of the star contracts it. So the contraction will happen and it will appear dim. But after that, it will be so dim and so energyless that the helium ions which gave their electron back, they will take it back. So they will release some energy and the star will again start to look bright after this. But if you notice one thing, if you are science enthusiast, you notice one thing, that it takes the atom, but after taking it doesn't become a stable helium atom, stable helium ion, you can say. It doesn't become that. That's why the star is not stable. Stable helium atom is still not here. Now you may say, why is this happening? मतलब अब वो हम पीरियोडिक टाइप से उसका पल्सेशन पीरियड हम क्यों काउंट नहीं कर पा रहे? मे बी इट इज़ डाइंग आउट. फॉर मैनी पीपल बिलीव दैट इट इज़ डाइंग आउट, दैट्स वाई. एंड यू कैन सी दैट दोनों पीरियोडिक इवेंट्स है, 30 years पे वो जाना और इसका डिम ब्राइट होना, पर ये पीरियोडिक क्यों नहीं है? लेट मी गिव एन एग्जांपल. You know the ice age which ended most of the life on earth? Ice age comes non-periodic. It is non-periodic every time, you can see, but the things which causes the eccentricity, wobble and tilt of earth, they all are periodic. But all three periodic motion cause a non-periodic ice age. Maybe that is what happening with the Polaris star, but I think we should be more concerned with the Betelgeuse because it can burst anytime open. The NASA has said it. So until then, Jai Bharat, Jai Hind. And if you learn anything from this video, please make sure to subscribe and like the video. Thank you. Have a nice day.